Solving polynomial equations. This will be the topic for our next lesson, and there are several ways that we can go about solving polynomial equations. What we're going to talk about in this video lesson are some of the factoring methods that we can use. Whenever factoring works, it's usually an easy process to go through. So let's take a look at our first example. In this case, we're trying to solve the equation 2x cubed minus 6x squared minus 56x equals 0. Now as you look at this, you want to look at each of your terms to see if there is a common monomial factor that 2x cubed, negative 6x squared, and negative 56 all have in common. And hopefully you realize that 2 and x are common factors in all three terms. So if I factor that out, then the 2x cubed divided by 2x will leave me with an x squared. The next term of negative 6x squared divided by 2x will give me a negative 3x. And then the negative 56x, when I divide that by 2x, I'll get a negative 28. And that's all still equal to 0. Okay? And so now, what I've got left in the parentheses here is just a polynomial. A quadratic. So this x squared minus 3x minus 28 now is just a quadratic, which we can factor using our quadratic methods. So we're going to be making two binomials out of that quadratic. So if we look for factors of 28, negative 28, that add up to a negative 3, we end up with an x minus 7 and an x plus, let's try that again. There you go, x plus 4. Again, still all equal to 0. So now we have three factors that we need to use the zero product property on. We've got the 2x, which could be equal to 0. We've got the x minus 7, which could be equal to 0. And we've got the x plus 4, which could be equal to 0. Any one of those factors could equal 0 in order to end up making the whole thing equal 0. So now we solve each one. Here I would get an x equal to 0 because I would divide both sides by 2. Here I would get an x equal to 7 because I would add 7 to both sides. And here I would get an x equal to negative 4 from subtracting 4 from both sides. So those are our three possible solutions to this equation. X could equal 0, x could equal 7, and x could equal negative 4. Excuse me. In the next example, we're still going to factor, but we're going to factor in a little different way by grouping. Now, even when we're doing other types of factoring, the first thing we still always want to look for is whether all of our terms have a common factor. Now, in this case, when we look at the x cubed, the x squared, the negative 4x, and the negative 4, there is not a common factor in all four terms. So we're going to proceed with our grouping method. And grouping works best when you have 4 terms in your polynomial. So we have our x cubed plus x squared. The next term is minus 4x. I'm going to change that to plus a negative 4x, and then the minus 4 equal to 0. And the reason I did that is because when I go to group 2 by 2, it helps if I can have an addition sign in between the two groups. Makes the process a little easier. So anytime you have minus in this spot, you're going to want to change it to adding an opposite before you put in your parentheses. So now from each group, from each parentheses, I'm going to factor a common monomial. So in the first parentheses, there is an x squared that both terms have in common, and that leaves me with x plus 1. In the second set of parentheses, I'm going to factor out a negative 4 so that my parentheses will also end up equaling x plus 1, because that negative 4 divided on this term and this term will give me the x plus 1. And this is the key to doing factoring by graphing, is that you want to end up with binomials which are the same. And now because I do have these binomials in common, that is the common factor that's going to come out, and the x squared minus 4 becomes the other factor. Now, when you look at these two factors, you need to realize that x squared minus 4 is a difference of squares. So we can actually factor this one more step by taking the x plus 1 and then splitting up x squared minus 4 into x plus 2 times x minus 2. And so now with our three factors, we are ready to excuse me, use our zero product property. And so if x plus 1 equals 0, x is going to be negative 1. If x plus 2 equals 0, then x will be negative 2. And if x minus 2 equals 0, oh, I'm running out of room here. Let's see if I can squeeze it on. X will equal positive 2. So my solutions here are going to be x equals a negative 1, a negative 2, and a positive 2. Those are my three solutions. Okay? Now, we also have a particular pattern that we can use. Just like we have a difference of squares, like we just used in the previous example, we also have a pattern for difference or sum of cubes. And the pattern looks like this. If I'm taking a cubed term plus another cubed term, that can be factored by taking the a plus the b in the first factor, and then in the second factor we would have a squared minus, let me redo that, minus a times b plus b squared. Okay, and the way I always remember this, is whatever this is what the first sign is going to be. But whatever that first sign is, this sign has to be the opposite. This one is always positive. That one's never going to change. It's just these two that could be a little bit different. Right here and right here. Okay? So the way I always remember it is whatever the first sign is, that's what goes in the first factor, and then this one will always be the other sign. So if I turn this around, a cubed minus b cubed, sorry guys, not sure if you're seeing the screen shrink or not, but so if we're taking a cubed minus b cubed, then my first factor is going to be a minus the b, because again we want to match. And then my second factor will be a squared plus ab, so again going opposite, and then plus b squared. So those are the two patterns for adding perfect cubes or subtracting perfect cubes. So in this case, if we're faced with the equation x cubed minus 8 equals 0, I can use the pattern, And I can recognize that if I have x cubed, then that means my a is just x. And if I have 8, then that means my b must have been a 2, because 2 cubed is what would give me 8. So I'm really saying I have x cubed minus 2 cubed. That is going to equal x minus 2, that's the a minus b part, and then x squared plus 2x plus 4. Now, when it comes to solving these, if we are only looking for real solutions, which is what these directions say, the only factor that's going to give you a real solution is the x minus 2 factor. And so we would have x equal to 2. This factor is almost always going to be imaginary numbers. And so that doesn't fit the real solutions that the directions are asking for. Now you could kind of see this if you used roots. I could have just said x cubed equals 8 by adding 8 to both sides. And then when I took the cubed root, I would see that x equals 2. So I get a matching answer. But there are times where the factoring is what we need, because not only can we solve this way, sometimes we also need to simplify by factoring first. And so we need to practice this method of factoring. So even though this is a possibility for solving, make sure that if your directions are asking for factoring, that you really are practicing the factoring method. And then just that first factor will actually give you a real solution. All right, so that gives you some examples of different ways to factor polynomials. In class, we will talk about what to do when you can't use any of the factoring methods and you still need to be able to solve a polynomial equation. And so until next class, have a good day.